Welcome to EDU World Space.
In this question, we have an incline that's 5 degrees from the horizontal. On the incline, there are two boxcars, A and B, connected by a coupling at C. And then they are both moving downward. Brakes are applied at A, so the mu k between A and the track is 0.5. The weight of A is 20,000 pounds. The weight of B is 30,000 pounds. So in the acceleration, since there's brake applied on A, we expect the whole system to be slowing down, so the acceleration is pointing up along the incline. So to solve this problem, we want to find the force at the coupling at C. So we'll first draw the free body diagram of the whole system. We draw it for A first. So on A, there's a 20,000 pound pointing downward. There's a normal force, NA, pointing this way. There's friction. There's also the coupling T. So and the acceleration is pointing up along the slope, and I'm going to put my coordinate system x and y in this way. So using Newton's second law, consider the forces along the x direction, and this is equal to ma. So we have T minus plus, so the friction is mu k times n of A, mu k and A minus mag sine 5 degrees equals to ma times A. And then forces along the y is equal to 0. So we have the normal force of A is equal to ma g cosine 5 degrees. And then we look at the free body diagram for the whole system. So it looks like this. So I'm just going to use a big block to represent 50,000 pounds of weight, and then there's a normal force of A and B, but the friction on it is due to the friction on A. Right, so and the acceleration is pointing up along the incline, so summation of forces along the x is equal to ma. So this is mu k na minus ma plus mb g sine 5 degrees is equal to ma plus mb g cosine a. There's no g. It's a combined mass times the acceleration. So we have three equations. So first we can find the acceleration of the system. So we have from 2, right? And A is 20,000 times cosine 5 degrees, and this is 19923 or 24 pounds. Okay, so you can substitute into equation 3. So you have 0.5 times 19924 minus 50,000 times sine 5 degrees divided by 50,000 divided by 32.2. Okay, so this is equal to 3.61 feet per second square. Okay, and then with this acceleration, we can put this back into equation 1. Okay, to find t. Okay, so and then from 1, okay, t is equal to ma times a plus mag sine 5 degrees minus k and a. Okay, so you have 20,000 divided by 32.2 times 3.61 plus 20,000 times sine 5 degrees minus 0.5 19924. Okay, and you calculate this, you get the tension to be 5980 pounds. Okay, so this is the answer for this question, and that's all.